Hi, in this video we are going to learn about a computer implementation of first order logic using this language called Prolog. So this is very different from any other programming language that you may have learned in the past. So generally when we talk about programming languages like C, Python, although their syntax is different, but what you can do with these languages is essentially the same. However, Prolog is fundamentally different because it is not really meant to do those kind of computations, although some of them can also be done in Prolog. But Prolog is specifically meant for logical inferencing system. Like when you learn first order logic, you had some given facts, and using that you could derive other facts. Those exercises you did manually by using a truth table or some process like forward chaining, backward chaining, or some kind of resolution. So Prolog is meant for a automated implementation of the same processes. This was developed around 1972, and it was also used in IBM Watson, which is a very prominent AI system. And nowadays, although its usage has somewhat declined because of the rise of other AI techniques like neural networks, but it is still used in several expert systems for decision making and planning, because in some systems you want the decision making to be very precise and use a lot of domain knowledge, and you can't take chances with the system learning from data, because in some critical applications the algorithm can learn all kinds of wrong things and may even be biased, which may not be acceptable. So specifically in some kind of critical systems, Prolog is still very much used for decision making as well as planning. So in this language you can basically describe the given facts in a text file. The text file is called a database, but it is not like a SQL database something. It is just called a database. And then you can load the text file into your Prolog terminal, and then you can give new statements which are called queries, and you can check whether these queries are true or false. So Prolog will do all the inferencing system for you, and it will give you whether the given statement is true or false. And if the given statement also has some unspecified variables, it will also tell you the values for which the statement is true. So before proceeding further, please install Prolog on your laptop. So the instructions are not in this video, but if you just Google for it, it should be very easy to find. On Mac or Ubuntu, it should just be a single command line entry, but on Windows you may have to download some exe file and install. So please do install Prolog before proceeding, because unless you try out these commands that you're going to learn, it won't really make sense to you. So like every programming language, Prolog also has data types, but these data types are very different from the data types of usual programming languages. And the data types in Prolog are called term. So the first data type is an atom. So it's a general purpose name which has no inherent meaning, and it always starts with a small letter. Okay, so if you can have X, Y, zebra, planet, etc. You can have numbers, you can have integers, or you can have floating point numbers. You can have variables whose values can change depending on the situation. It can be a string of characters or numbers, and it has to begin with a uppercase alphabet or underscore. So if you have a name which begins with a small letter, then it's an atom. If it begins with an uppercase capital letter, then it's a variable. Then the most important thing is what is called a functor. This is basically a predicate that you might have learned in first order logic. And this is also the crucial differentiating factor between first order logic and propositional logic. And this is basically the data type which defines the relationship between various atoms and various variables. And as I just mentioned, these functors are also called predicates, and due to this, first order logic is also called predicate logic. Then you can also have a collection of variables, numbers, and atoms in what is called a list. So this is an ordered collection of items. So this list is like the list of Python, and the syntax is also kind of similar. So functors, as I mentioned, are the most important data type in Prolog, because it is functors. It is through functors that you do all these kinds of complicated computation and inferences. And the number of argument a functor takes in Prolog is called its arity. Okay, so if we have a functor called red bracket x, and this checks if the variable x is red or not, its arity is 1, since it only takes one argument. And this functor, so it can be denoted by red/1. So what this means is that red is a functor which takes one argument. If you have another function called father x comma y to check if x is a father of y, this takes two arguments, and so its arity is 2. So you can denote this by father/2. So if you have, let's say king/3, it would be a functor of arity 3. So pause for a while, pause this video, and first answer this question: what is the arity of exam XYZ? Okay, I'll not answer it because it is very simple, but I just suggest you to pause for a while and just answer this so that it can better stick in your memory. So now that we have defined the various data types, we need to now learn how do we actually represent various kinds of facts and rules in Prolog. And then using these known facts and rules, we are going to make inferences, and then we are going to prove theorems. Okay, so now let's say we have a fact that apple is red. We had a functor called red of x which checks whether x is red or not. And now we want to state the fact that if x is apple, then red of x will output true. So what that means is that red of apple is true. So we create a database which is basically just a text file, and we write red bracket apple, and remember the full stop at the end. Okay, this is necessary to say that the sentence has ended. Okay, like in C, we often use a semicolon. In Prolog we use a full stop. Okay, if you do not have a full stop, then you will get an error. So red bracket apple tells Prolog that apple is red. Okay, and when you write red of x, and if x is apple, then this functor will output true. So this is what is called a fact. Now if we want to have a rule that if x is an animal if x is a cat. So now we have two functors, animal of x and cat of x, and what we want to say is that if cat of x is true, then animal of x is also true. So this is the format in which we write it, that animal of x colon hyphen space cat of x. Okay, now note that this syntax is reverse of implies. Okay, in first order logic we would write cat of x implies animal of x, but here we are writing animal of x colon hyphen cat of x, and again there is a full stop. Okay, so again remember the meaning of this rule. Okay, that animal of x is true if cat of x is true. Okay, this format is very important to remember, otherwise you will again make mistakes. And here in first order logic, again if we write this sentence, we will put a for all of x before this, but in Prolog that is not necessary, because it is assumed that every rule that you're writing there is a for all which is assumed. So now let's use this sentence, and let's do some inference using Prolog. So our sentence was x is an animal if x is a cat. So now just take a text file and write these two lines inside it. Okay, again don't forget the full stop. So write animal of x if cat of x full stop. This is a rule. Then let's add a fact called cat of Tom. Okay, so this means that if x is Tom, then cat of x will output true, and put a full stop at the end. Name that file db.pl. This can be named anything, just put a .pl at the end to specify that this is a Prolog file. So this can be done in any text editor. Okay, don't use a Word doc because that is not a text editor. Use a text editor for doing this. Okay, then you should open the Prolog terminal. Basically just open a terminal on either Mac or Ubuntu or Windows, and in Mac or Ubuntu gprolog would work. In Windows you need to find what is the equivalent of gprolog. And once you are now inside the Prolog terminal, you will see a question mark. There you write these commands. Write first square bracket db square bracket close dot. So this will input the database file into your Prolog terminal. So remember that you should open the Prolog terminal in the same folder where you have created the db.pl file. So open the terminal, then go to this folder where this file is there, and then get inside the Prolog terminal. Otherwise you will make a mistake. So do square bracket db dot. This will insert the database entries into your Prolog terminal, and now you can do inferences. So again, type these three commands and see what output you get. So first type animal of Tom dot, animal of Jerry dot, and animal of Jerry with a capital J dot. Okay. Now again, pause this video for a while and try this out, and then once you are done, then resume this video. That way you will be able to better understand what I am going to talk about. So now if you do this, what you will find is that if you give animal of Tom dot, you will get yes as expected, because cat of Tom is true, and so cat of Tom is true will imply that animal of Tom is true, so you get yes. Animal of Jerry answers no, because there is no fact that Jerry is a cat, so that's why Jerry is not a cat, and so Jerry is not an animal. What is interesting is this last one, where you have animal with inside Jerry, but where J is capital. So what this algo is doing is that it is assigning the value of Tom to Jerry and then answering yes. Okay. Why did this happen? Because here your J was capital, and as I just mentioned earlier that in Prolog, anything that starts with a capital letter or an underscore is considered to be a variable and not an atom. So that's why you need to be very careful with capital letters and small letters, because Prolog is case sensitive and the meaning changes completely. So now let's take another example which is slightly more complicated. So we have now three functors. We have son of x comma y. This is true if x is a son of y. Father y comma x is true if y is the father of x. And male x is true if x is a male. Okay. So in first order logic, we would write male of x and father of y comma x would imply that son of x comma y is true. Okay. In Prolog, this gets reversed. So we have to write first, we have to write son of x comma y, and then we have this symbol which means if, and then you have male of x comma father of y comma x. So what does this mean? If male of x is true and father of y comma x is true, then son of x comma y is true. Okay. So this comma in Prolog refers to conjunction. Okay. This is the and symbol in Prolog. Okay. So now please update your db.pl file to contain the above rule, and also add two more facts which I am not telling you how to write. Now you should be able to do it on your own. Write two facts that Rakesh is a male and Srinivas is his father. Okay, so just to give you a hint, so you have male of x is true if x is a male, so you can write Rakesh in place of x, and similarly you can modify this father y comma x. You can write suitable entries over here to signify that Srinivas is the father of Rakesh. You do that, and then you again enter this in your db.pl file, then again reload the db.pl file in your Prolog terminal, and then give this command to check whether Rakesh is son of Srinivas or not. Is Prolog able to make the inference or not? Again, remember that the specific object names have to start with small letters, and variables, they always start with capital letters. Okay. So again, take a pause in this video, do this exercise, and once you are done, then resume the video once again. That way your learning will be much better. So now, I hope you have got that right and you have been able to successfully do that small exercise. So now, did you notice that this rule was only partial? Because x can be son of y even when y is mother of x. Okay, y doesn't have to be father of x. Okay, so we need one more functor and one more rule. We need a new functor called mother of y comma x, which will be true if y is mother of x. So you need to add this rule in addition to the previous one in your Prolog database file. Now remember, in Prolog, if you have this additional rule, so you have the same left hand side, this does not override the previous one. In C or Python, if you had two equations where the left hand side was the same, the second one will override the first one, but in Prolog that doesn't happen. Okay, this becomes an additional rule that Prolog can check to determine if son of x comma y is true or not. So in some sense, this is like a OR operator or an OR connective. So if this is true, then son of xy will be true, or if this is true, then son of xy will be true. So when we add the second one, the first one is left intact. So now let's again update the DB file with these rules, so that now we have son of x comma y will be true if x is male and y is father of x, or it will be true when x is male and y is mother of x. And then you have three facts which we know, that Rakesh is a male, Srinivas is father of Rakesh, and Urmila is mother of Rakesh. So please again write this in the db.pl file and then try out these following queries and see what you get. Okay, male Ramesh. Okay, so here this is Ramesh, not Rakesh. Okay, then son Rakesh comma Srini dot, then son Rakesh comma Urmila dot, and then try out son x comma Urmila dot. Okay, again take a pause in the video, try out these various commands and see what you get. So here in these rules that we had, the left hand side of this rule is called the head of the rule. Okay, and the head of the rule always contains a single functor. So the left hand side can never contain multiple functors. The right hand side is the body of the rule. This can contain multiple functors which are joined by conjunction or disjunction or negation or other such connectives. Okay, so conjunction is denoted by comma, disjunction is denoted by semicolon, and negation is denoted by backslash and plus. Okay, now in the body of the rule, we generally do not use disjunction because it may cause confusion by unnecessarily making the rule quite big. So instead we write the rules in two separate lines. Okay, for example, here this male of x comma mother of y comma x could have been written in the first sentence also by using a semicolon, but we wrote a separate line just because it makes it more clear to understand, and Prolog basically treats this as a disjunction. Okay, this is just a a programming preference that people use, but it is not necessary. You could write everything in one sentence if that is what makes you feel more comfortable. So now let's see what happens when we try out negation. Okay, so take these facts and write this in your db.pl file, and then in the terminal give the query mother capital Y a comma capital X, and then of course you need to put a full stop over here, and then try it out again. Take a pause, try it out and see what you get, and then get back to this video. Okay, so here rest everything is same, but here what you're doing is that you are putting a negation over here. So what does this rule mean? It means that if X is child of Y and Y is not a male, then Y is mother of X. So this is the rule, and these are the three facts that we have, that Rakesh is child of Urmila, Rakesh is a male, and Srinivas is a male. Okay, now try a slightly different formula. Okay, so here we had this negated male later on. Let's change the order and put the negated male before child of X comma Y. So now in first order logic, this will make no difference. Okay, in first order logic, whether you write this or whether you write this, the meaning is the same, the answer is the same. But in Prolog, it makes a difference. Okay, again, before I explain what happens, I would again recommend you to try it out and see what you get. Okay, because then you will properly understand what's going on. So here, when you give the query mother y comma x, the answer is no. Okay, why is the answer no? Because here what happens is that Prolog first checks for this rule, that male of y negated. It finds that male of Rakesh is true and male of Srinivas is true. So for both these facts which we know, male of y is true, and so the negated is false, and so false and anything is false, and so that's why it gives an answer of no. But in the previous case, here what happened is that you had child of x comma y. Now what Prolog does is that it first searches to satisfy this. It finds one fact, child of Rakesh comma Urmila. So now x is assigned to Rakesh, y is assigned to Urmila, and now it checks if male of Urmila is false. It does not find male of Urmila as a fact, and so it is this whole thing now becomes true, and so true and true will give you true. And so that is why in Prolog you have to be very careful sometimes about the order of the terms that you have in the conjunction on the right hand side of the rule. Okay, so this is something slightly different from how first order logic would behave, that when you implement this in a code, you have to be somewhat careful. Again, don't just listen to what I'm saying, do try it out in Prolog terminal. That will help you in properly understanding what's going on. So now in Prolog, like we do in other programming languages, you can also do various kinds of operations. Okay, so Prolog allows you to do standard arithmetic operations using addition, subtraction, multiplication and division. And in addition, you can also do comparison of various variables using the standard operators. So you have the equality operator, which is the arithmetic equality. In C and Python, usually we use equal to, but in Prolog you use equal to with a colon in between. You have inequality, which is given by this, less than equal to, greater than, and greater than equal to. So these four are the same as usual, but these first two arithmetic comparison operators are different from conventional programming languages. Okay, so again, please open a Prolog terminal and type these queries and see what you get. Okay, so again, this equal to is not what does the job in Prologs. In Prolog you need to write is. Okay, so see what you get when you write x equal to 1 plus 1. I will not tell you, try it out on your own. So when you do x is 1 plus 1 dot, then the value of 2 is assigned to x. Okay, when you do x is 1 plus y, then try out what you get. And when you write x is 5 comma x is 1 plus y, then the value of 5 plus 1 6 is assigned to x. So I'm not telling you what you get for x equal to 1 plus 1 and x is 1 plus y. This I would recommend you to try out on your own and see the answer. So now let's get into slightly more complicated domain. Let's write functions to do various tasks. For example, when you start learning C or Python, you write small programs to accomplish certain tasks, and that is what we are going to do in Prolog also. So Prolog can also be used to do searching, sorting like you do in Python or C, but that we will see later on. First, let's see some simple examples of how you can do very simple kind of problem solving using Prolog. So let's write a program to compute the sum of two numbers. Now, of course, for this you don't need to write a function, you can just use the operator plus, but here I'm just writing the function just to help you understand how functions work in Prolog, that how do you even go about writing such functions. And then I've taken this example because it's the perhaps the simplest example which is possible. So if you had, let's say Python, you would write it in this way, that you have def sum of x comma y, then you have z equal to x plus y, and then you will return z. Okay, so you explicitly computed x plus y, assigned it to the variable z, and then you return z. This is typically what you do in C also, although the exact syntax will not be the same, but the logic and the flow of program is basically the same. But in Prolog, such a structure does not exist. Okay, so here it is a very, very different structure, and it will take some time to get used to this particular way of doing things. So in this Prolog, you again open your db.pl file and write this as your fact. Okay, so here your sum is taking 3 arguments and not 2 arguments. Okay, because in Prolog there is no such thing as a separate return function. The return thing is embedded in the function itself. So whatever you want to return, that has to be incorporated in the function itself. So x and y are the input arguments and z is the output argument, and everything is an argument in sum. So the arity of sum is 3. And then you have this is true if z is x plus y. So what it does is that when you run this program in your terminal, you give this query sum of 4 5 z. So what it will do is that it will check, is the right hand side true or not. Now in the right hand side, x is 4, y is 5, so they are assigned. So it will find the value of z for which this can be made true, and if it can find such a value, it will assign that value to z. So after searching, it finds that z equal to 9 does the job, and so it will then assign that 9 to z, and then that will become true. Okay, so Prolog can only check the truth value of given functors and nothing else. So everything has to be written keeping that thing in mind. Okay, so please do try it out, and I hope you get the right answer. But after that, try out this variation also. Okay, here you have sum of x, y, z, but on the right hand side you have w in place of z. Okay, try this out, and in the query in the terminal write the same thing, sum of 4 5 z, and let's see what do you get. Okay, again try this out because this will help you in understanding what exactly is going on. Okay, so now after you have run this thing, please be very careful. Think about the output very carefully, because if you can understand what is going on, you would have understood most of what Prolog programming is all about. So now let's take some more complicated examples, since you are hopefully now familiar with the basic idea of how functors in Prolog works. So let's write a program to compute the maximum of 2 given numbers. As I just said, in Prolog there is no concept of a separate return function, and whatever you want to output has to be included in the initial functor itself. Okay, so now if you want to compute the maximum of 2 numbers, the functor obviously has to have 3 input arguments. The 2 are the input arguments, and the third one is to store the output. Okay, so what do? The idea is simple. So this function, it takes 3 input arguments and it assigns the max value of the first 2 arguments to the third variable. Okay, so here in the first one, what does it do? If x is greater than or equal to y, then it will assign the value of x to the third argument. If x is smaller than y, then it will assign the value of y to the third argument. So what this means is that whatever you give it as the first 2 inputs, the third argument will become the larger among these 2. Okay, so again, as usual, write this in your db.pl file, then load this db.pl into your terminal, and then run these queries. Again, there should be a full stop after all of them. Okay, max 2 comma 3, put a full stop, max 2 comma 3 comma z, put a full stop. Then here you have max 2 comma 3 comma small z. Okay, here see what happens. Okay, this z is different from this z. Then again try one more, max of 4 comma 1 comma capital Z. Again try out what exactly happens in this case. So if you have done this, what will happen is that max of 2 comma 3, this will give you an error. And why is that so? Because the function is expecting 3 arguments, whereas you have given it only 2 arguments. This one gives the correct output, and the answer, which is 3, is assigned to the variable Z. 23Z gives no as output. Why is that? Because Z is not a variable. Because again, remember, all the variables start with capital letters or an underscore. So Z is not a variable, and so this answers no. So now, this was a very simple kind of programming. Slightly more complicated programs will require using loops. Okay. In C or Python, again, there is a for loop, there is a while loop, and there are ways of implementing loops. But in Prolog, there is only one way of implementing a loop, and which is through recursion. Okay, so a recursive function is basically a function that calls itself to solve a problem, and it does that by breaking the problem into smaller sub problems. Okay, so if you are not familiar with recursion, I would again suggest you take a pause over here and do some practice of recursion using any other language that you're familiar with, like C or Python or even Java, for example, and then get back to this video. Okay, because if you are not familiar with recursion, then it will be somewhat difficult for you to follow what's going to come, because recursion itself is a slightly involved process, and with Prolog it becomes slightly more challenging to understand. So assuming that you understand how recursion works, so let's take a simple example that we want to print integers in decreasing order starting from some capital X up to 0. So this capital X is input by the user. Okay, so far we have not seen how to print anything in Prolog. So the command is write bracket X. So this will print the value of capital X to the terminal. And after this write comma X, we have a NL, which basically means a new line. So when we have write of X comma NL, what it does is that it writes X and then it inserts a new line, so that the next write of X command is executed on the next line, so that you have a clean visible output that you have. So here we have a inbuilt functor called integer of X. This checks if X is an integer or not, because we want to print only integers which are starting from X. So if X is not an integer, so if the user inputs something else, then that should not be printed. Okay, so write these commands. I will explain to you how this works. Don't worry about it right now. First, just write this these two commands in the db.pl file, and run these two queries in the terminal, and then see what is the output you get. Write countdown of 4 dot and then write countdown of -5 dot and see what you get. You can also try out some floating point numbers like countdown of 9.6 and see what do you get. So like we have integer of X, we have also some other inbuilt predicates also, like number, which checks whether the given input is a number or not. So the /1 obviously refers to the arity of the functor. You have float, which checks whether a given variable is a float or not, whether it's atomic or not, whether it's a variable, whether it's a non-variable, whether it's a compound term, or whether it's a ground term. Okay, so there are some other inbuilt predicates also, which I am not getting into in this video, but as and when need arises, I'm sure you will be able to figure it out. Okay, so again, please take a pause. Pause now, write these two lines in your db.pl file and run this command and see what you get. Okay, so I'm assuming that you have done that. So now let's understand how this program is working. So the first rule checks whether X is just positive or negative. That's all. It doesn't do anything more than that. So if x is negative, it just outputs true, and there's nothing more that is done. And the program actually works as long as x is positive. And why is this recursive? Because you have a countdown on the left hand side and you have a countdown on the right hand side. So this is the essential property of recursion, that you have a function call from within the function definition. Okay, so what does this rule 2 do? The rule 2, it first checks whether x is an integer or not, then whether x is greater than equal to 0 or not. As long as it is greater than equal to 0, it will write x, and then it will make x 1 less, assign it to nx, and then call the countdown function again with the updated value of nx. Okay, this is what makes it recursive. So let's take a particular query, countdown of 4 in Prolog, and let's see what happens. So initially x is 4, rule 1 will return false because x is positive. And now so my algo will check rule 2. If the functors on RHS2 are executed and if they return true, okay, then nx is now 3 and countdown 3 is now checked. Okay, so in step 2, when countdown of 3 is called, first one again gives false, and when you check the second one, countdown of 3, this is again true, this is true. The program writes the value of 3 on the terminal. 3 minus 1 becomes 2, 2 is assigned to nx, and then countdown 2 is called. Okay, and now when countdown 2 is called in Prolog, it means that countdown 2's truth value is checked. Again it checks the truth value over here, this gives it false. So it checks whether this thing is true or not. Again it goes into this loop, then 2 becomes 1, countdown of 1 is called, and so forth and so forth. Okay, finally when nx becomes -1, rule 1 will return true, and then the execution will stop. This way of thinking may not be very familiar to you, so I would strongly recommend you that spend some time, think about it, absorb it fully, and then move on. Because if you understand these simple programs, it will be much easier for you to understand the slightly longer programs that we are going to see very soon. So another very important data type in Prolog is what is called a list, and this allows you to write programs where you have lot of different numbers or characters that you need to take care of. So the way you write lists in Prolog is similar to the way you write it in Python, that you have square brackets and you separate each item with a comma. Okay, so here comma does not mean conjunction, it just means that these are elements of a list. Okay, so when you have square brackets A, so this is a list of just one atom, or it is also called a literal. A comma B is a list of 2 atoms. A comma capital X comma sun X comma Y is a list of 1 atom, 1 variable, and a functor slash predicate. A very useful notation in Prolog is this straight vertical line. What this does is that it splits the list into its head and its tail. Okay, so if you write this A equal to square bracket H vertical line T, it will assign A to H and T will become a empty list. Okay, if you have a list with 2 elements and you give equal to HT, H will become A and T will become the second element in the list. If you have ABCD equal to XY straight line T, what you will get is X equal to A, Y equal to B, and T equal to C comma D. Okay, so whatever number of elements are written initially, they will be assigned one element from the list, and everything that is remaining will be assigned to what is called the tail. Okay, so this is a very crucial concept that we are going to use in the programs that follow. So again, please pause the video over here, try this out on a Python terminal, and then proceed further. So try this out. Query in your terminal, write 34A6D equal to WXY vertical line Z full stop, and then see what you get. Okay, again, please do try it out, because then you will understand what's going on. So let's write a simple program that uses a Python list. Okay, so earlier we had seen a program to find maximum of two numbers. We are going to later see how to find the maximum of numbers in a list. But before that, let's do a simpler problem. Okay, that how do you find the sum of a list? Okay, we have a list with some numbers and we need to find the sum of all these numbers. Okay, so there are just two lines that you need to write in your db.pl file. One is list underscore sum. This is the name of the function. It has a empty list comma 0 dot. So what does it say? It says that if the list is empty, then the sum is 0. Remember that in Prolog you do not have a separate return function. So whatever is supposed to be the output, that has to be incorporated in the the arguments of the function itself. Okay. So the second one is what does the actual computation, which is that you have list underscore sum, you have a input list, you divide that in head and tail. Okay, so you have the first element, which is the head, and everything else becomes the tail. This one argument is what captures the value of the sum. This is true if the right hand side is true. So in the right hand side, what do? We again call this function, but with only the tail and the second argument, which is sum temp, which is the temporary sum, which captures the sum of the tail. Now the second one immediately, basically then calls back this function. Again, this tail is divided into two parts, the head and the tail. Again, this function is called again and again. Finally, you come to sum is head plus sum temp. So this sum is computed for the last element, and then you backtrack till you reach the first element, and the total sum is then output in your terminal. Okay, so please try out this in your Prolog also. Write these two lines in your db.pl file and then load the db.pl in the Prolog terminal and try out these two queries to see what output you get. Okay, so to better understand what's happening, so let's take a particular query, that list underscore sum 368 comma z dot. The first thing that happens is that it goes list underscore sum. So this is the head and tail division, 368 sum. This is true if list underscore sum 68 sun temp comma sum is 3 plus sun temp. If both these things are true, then the left hand side will output true. So the argument, the program has to now check if this is true. So that goes to now step 3. This is list sum 68 sum. This is true if list sum of the tail sun temp, then sum is this. Then the Prolog program wants to check this. So again, this is divided into a head and a tail. So now the tail is empty. Now when the tail is empty, you need to check this first rule. So the first rule gives you an output of 0. So now the program does backtracking. The 0 goes to this sun temp, it is added to 8. Then this sum goes here, that is added to 16. Then the sum goes here, it is added to 3, and the final sum is output as the variable z. Okay, so this is how the recursion works in the case of Prolog programming. So now I'm giving you a program and asking you to figure out what this program does. Okay, it's a very, very simple program. If you have understood how the sum is working, it should be fairly easy for you to figure out what this is doing. I will not give you the answer again. So please write this in your db.pl file and run suitable queries on the Prolog terminal. I will also not tell you what queries to run. So run some queries, think on your own on the Prolog terminal and figure out what this program is doing. Okay. Another question, once you are done with that, try out this one. You have func list new list, which is func list empty list, then new list. This is a slightly complicated program, but write this in your db.pl file and run some queries on this on the Prolog terminal. Okay, so this is slightly more complicated than this one. This is fairly straightforward, but here you will have to spend some time in thinking. Again, I'm advising you to do that so that you properly understand what exactly is going on. Okay, so again, take a pause, write this in your db.pl file, run some queries and see what you get. So since this one is somewhat complicated, the answer I'm going to tell you, and that is that what this program does is that it reverses the list. Okay, so if you give it 2 arguments, then it will reverse the list. If you give it 437 comma z, it will output z equal to 734. But if you give it 3 arguments, it will reverse the first list and concatenate the second list to it. Okay, and you want to understand how exactly is the path that this recursive algorithm is taking, you can use this query in Prolog. So you have trace, comma, and you have func of 437 comma z. So this will trace out the entire journey that the program is taking from start to finish. Okay, so let's try one more example. Type out this program again in Prolog and see what exactly is happening. So this first 2 lines are what we had done earlier, is to find the maximum of 2 numbers, but now you have 2 additional lines. One is func, you have a x inside a list, then you have comma x full stop, and then you have another functor which is defined like this. Take a minute, look at it carefully, write it in the db.pl file, and then run suitable queries on the Prolog terminal to understand what exactly is happening. Okay, so again, pause this video for a while, run this thing, see what is happening, so that you can better understand what's going on. So now in Prolog, you can also implement various kinds of searching and sorting algorithms also. This is the Prolog code for depth first search. You can also write a equivalent code for breadth first search. I am not going to do it, but I encourage you to check it out. So here this depth first search is a function that we have defined, but it is using a function called member node1 comma path. Okay, so it is over here and it is a negation over here. So this is an inbuilt Prolog function and it checks if this node1 element is a member of the list path or not. Okay, so path is a list which contains the nodes in the path from point A to point B. Okay, so here I've given you this depth underscore first underscore search functor definition, but there is one inbuilt function is there called member, but there's another functor called s which I have not defined, which you need to define, and that functor should check if node and node1 are connected through an edge or not. Okay, so what you do is that if you are, let's say, given a graph which has, let's say, 10 nodes, so you will have, let's say, 10 nodes named R1, R2, R3 up to R10. So if, let's say, R3 and R6 are connected, then you need to write a fact which says S of R3 comma R6 is true and S of R6 comma R3 is true, because it's an undirected graph. Okay, so you need to write rules like this, or you need to write facts like this to tell your Prolog that these are the nodes which are connected to each other. Then you need one more fact, which is the goal node, that which is the target node that you want to reach. So again, in your db.pl file, you need to write, let's say, if, let's say, reaching R7 is your target, and you need to write goal of R7 dot, that will signify that R7 is the final goal that you want to reach. Okay, so again, my suggestion, take any arbitrary graph that you want and write the facts to denote which nodes are connected to each other through a single edge, and then execute this command and then run trace on it to understand how this is working. Okay, so the simple point to understand how this is working is that if my node is a goal node, then this will output true, and then the program is over. But if this is false, then it will go over here. And if, now my S node and node 1 are connected. So whichever node is connected to node 1, that will be assigned to this, node 1. It will check if node 1 is already a member of the path or not. If it is not, then it will do a depth first search starting from node 1 onwards. So from one node that it is starting, it will go to a node 1 which is connected to it, and then it will perform depth first search from node 1. So that is why it is depth first search. If it was breadth first search, then it will not do a search starting from the node immediately, but it will look at all the nodes first which are connected to node, and then it will go at the lower levels of the graph. Okay, so it is depth first search because it is going from node 1 to it is going from node to node 1, then node 1 to further down and further down till it finds a suitable goal, or it again then backtracks and goes through other options which are available to it. Okay, so this was a short introduction to Prolog programming language. Again, to understand this properly, you need to try out these various functors in your terminal, only then it will make sense to you. So please do try it out, and if you have any queries, feel free to reach out to me. Thank you.